For decades, we've called Venus our sister planet. It's about the same size, made of the same stuff, and is right next door. But we've often seen it as the evil sister, a toxic, scorched world. For a long time, the prevailing view was that its geology had ground to a halt. But what if we've been wrong? Recent, cutting-edge computer simulations are painting a dramatically new portrait of Venus. One where the ground itself is alive. The models suggest that colossal systems of cracks are actively deforming the planet's surface. This isn't ancient history. Evidence points to geological processes happening in the geologically recent past, or even right now, driven by a tremendous heat engine deep inside the planet. What colossal forces are at work on Venus? And what does it mean if a planet we thought was quiet is actually tearing itself open from within? The portrait of a quiet planet. To understand why this new evidence is so revolutionary, we first need to look at our previous picture of Venus. When NASA's Magellan spacecraft pierced through the planet's thick, sulfuric acid clouds with radar in the early 1990s, it revealed a world unlike any other. We saw a surface covered with volcanoes and strange circular structures called coronae. But what we didn't see was just as important. There was no convincing evidence of a global, Earth-style system of plate tectonics, the engine that constantly recycles our planet's crust. This led to a leading hypothesis, that Venus had what's known as a stagnant lid, a single, thick, and mostly immobile crust. While some models suggested more complex behaviors, the general picture was that the planet's surface was largely locked in place. The planet's geological heart, it was thought, was beating much more slowly than Earth's. To explain the strangely young-looking surface, which has far fewer craters than the Moon or Mars, some scientists proposed a dramatic theory. One prominent idea was that around 500 million years ago, a catastrophic pulse of volcanism had completely resurfaced the entire planet in a global flood of lava. After that, the theory went, Venus cooled and major geological activity wound down. It's important to note, however, that other scientists have long argued for more gradual or regional resurfacing processes. In this view, the enormous canyons and rift valleys we saw, known as chasmata, were largely treated as ancient fossils. They were magnificent scars from a more violent era, a time of great upheaval that ended hundreds of millions of years ago. For a long time, Venus was a planet whose geological story seemed to be mostly over. The cracks in the theory, but Venus, it turns out, is full of surprises. For years, scientists have found hints of active volcanism, chipping away at the idea of a dormant world. But the real game changer has come from a new way of looking at the planet, not with a telescope, but with supercomputers. Researchers, including a team at ETH Zurich, have developed sophisticated, three-dimensional simulations of Venus's interior. These models are like a virtual planet in a box. They allow scientists to input Venus's hellish conditions, the extreme heat, immense pressure, and crust composition, and simulate how that crust would stretch, break, and deform. And these advanced simulations revealed something remarkable, a hidden geological clock. The models showed that the shape of a rift valley could hint at its age. Here's how it works: when a rift is young and actively pulling apart, the hot, buoyant material from the mantle below pushes upward. This creates high, broad ridges along either side of the rift, known as rift flanks. But, according to the models, once the stretching stops, these flanks begin to cool, relax, and slump down over geological time. On a world like Venus with very little erosion, this gravitational relaxation is the primary way the landscape changes. The models provided a clear signature: high, wide rift flanks could mean a rift is young and possibly still active. Lower, slumped flanks would likely mean a rift is ancient and dead. For the first time, scientists had a tool to help distinguish the living from the long dead. A world in motion. Armed with this new tool, scientists went back to the real-world data collected by the Magellan mission 3 decades ago. They compared the topography of Venus's massive rift systems to the signatures generated by their simulations. The results showed a compelling match. In several of Venus's largest rift systems, including the vast networks known as Ganis, Dali, and Devana Chasma, the real-world topography displayed the distinct signature of youth. Their broad, towering flanks were strongly suggestive of the young and active rifts in the computer simulations. This doesn't come with a precise timestamp, but the implication is profound. It suggests these colossal features are geologically young and raises the tantalizing possibility that they could still be evolving today, or only ceased moving in the very recent geological past. So, what's driving this immense activity? The prime suspect is a process familiar to geologists on Earth: mantle plumes. Imagine giant, superheated blobs of rock, rising like a lava lamp from deep within Venus's mantle. As these plumes push up against the underside of the rigid crust, they cause it to dome, stretch, and eventually crack. This is different from the global conveyor belt of plate tectonics we have on Earth. Venus doesn't seem to have separate plates that crash into each other. Instead, these plumes appear to create localized zones of intense deformation, pulling the crust apart in specific regions. Think of the East African rift here on Earth, where the continent is slowly being pulled apart. The forces on Venus create similar features, but on a world with a fundamentally different tectonic rulebook. It's a uniquely Venusian style of geology, one that we are only just beginning to understand. The scale of the upheaval, the sheer scale of these features is difficult to comprehend. We aren't talking about simple cracks. We are talking about vast, interconnected rift systems. While individual rifts like the Dali and Devana Chasma system can extend for 7,400 kilometers, the total length of all of Venus's rifts is estimated to be around 40,000 kilometers. These are not just features on the landscape, they are the landscape. Even more startling is the potential speed of this process. The new simulations suggest that if these rifts are still actively spreading, they could be widening at a rate of a few centimeters per year. The models estimate a possible range of 3 to 10 centimeters annually, which is comparable to the speed of some of the fastest moving plate boundaries on our own planet. This is a highly model-dependent estimate, not a direct measurement, but it points towards something far more dynamic than a quiet, cooling world. It's evidence of an energetic interior still powerful enough to reshape the surface in dramatic ways. A new Venus. This discovery helps shift our picture of Venus. The old idea of a planet with a completely stagnant, inactive lid is giving way to a far more complex and exciting reality. Venus appears to have its own brand of geology, a unique tectonic style that is neither Earth-like nor completely dead. It seems to be a planet that is very much alive on the inside. This has huge implications. An active mantle powerful enough to create vast rift systems also means that volcanism might be more widespread and more recent than we previously imagined. Instead of a single, ancient cataclysm, perhaps Venus has been continuously, or at least episodically, active throughout its more recent history. What's more, an active interior could be a crucial source for the planet's famously thick atmosphere. Active rifting and volcanism would release gases from the planet's interior. This outgassing could be constantly replenishing the dense carbon dioxide atmosphere, helping to sustain the extreme greenhouse effect that makes Venus the hottest planet in the solar system. It raises the possibility that the surface and atmosphere are linked in an active, ongoing cycle. The quest for an answer understanding Venus is about more than just satisfying our curiosity about a neighboring world. It's a critical natural laboratory for understanding how planets work. Venus and Earth started as twins, but one became a temperate haven for life while the other evolved into a hellscape. Figuring out why their paths diverged is one of the biggest questions in planetary science. These simulations have given us a powerful new theory, but they are based on data that is now over 30 years old. To confirm these findings, to catch the planet in the act of changing, we need to go back. And that's exactly what we plan to do. A new decade of Venus is on the horizon, with multiple missions from NASA and the European Space Agency set to investigate. NASA's Da Vinci mission, planned for launch around 2029 to 2030, will plunge a probe through the atmosphere to measure its composition, searching for chemical clues of recent volcanic activity. ESA's Envision mission, targeting a launch in the early 2030s, will use radar to search for tiny changes on the surface over time, the ultimate smoking gun of an active world. And NASA's Veritas mission, now aiming for a 2031 launch after some delays, plans to create incredibly detailed 3D global maps to scrutinize these rift flanks for definitive proof of their age. These future missions could transform our models and theories into direct observation. If you find the idea of seemingly dead worlds coming alive and the search for answers on other planets as fascinating as we do, make sure you're subscribed to see the discoveries that lie ahead. Conclusion: we stand on the cusp of a revolution in our understanding of Venus. The image of a static, dormant planet is being fractured, replaced by one of dynamism and immense power. The evidence suggests a world with a beating heart, one that is stretching, shifting, and reshaping itself. The great chasmata of Venus are no longer just ancient scars. They are clues. They are the battlegrounds between the planet's rigid crust and the immense heat churning below. They are the places where Venus is revealing its deepest secrets. The question is no longer just what Venus was, but what it is becoming. And soon, we may finally have an answer.